that we had. Did the 73 wells, right? We built a whole bunch of models from here that we presented in Midland the other week. What I want to do is I want to test out these other modules against this. So one of them is like this pin inversion. This is a physics-informed neural network. So, we could train this thing using physics-based equations. It's got all these learnable parameters, right? We can select these things, where it's going to figure out, all these different endpoints that we've got in here. We got to be careful about some of this stuff. Most of these should be about correct, for mineral endpoints and things. But the idea is that we give it a formation top set that it'll also use. So I think we have got that tops ML in here, right? And then we can we can scan the wells, and we can set, these things equal to, so let's say input curves, right? This is sort of cumbersome until you set the filtering up, but you add DTC, put gamma ray in there, neutron, PE, bulk or resistivity, right? Actually, I think, yeah, we gotta undo this. I screwed this up. It's been so long, I don't even know what I'm doing anymore. So you have to tell it. It's on it. Okay. And then you go to gamma ray. You tell it gamma ray. Then you go to neutron. You tell it neutron. Then you go to PE. Tell it PE. Resistivity. This time we have to do the log 10. And then bulk density. Bulk density. So now I got them all in there, properly classified, right? And then I can come in here, I can hit scan wells or whatever, and it kind of didn't pick that up right. But these are all going to be from the mineral solver set. This is a pain in the ass to have to do this, but once you set it up once, you can just leave it, set it and forget it, save it or whatever. Now, the thing about this is I've got this set up where it's assuming there's anhydrite and stuff, but you can change that. So we'll put the clay, the lime, dolomite, where the hell is quartz? I can't see it. There it is. We'll put TOC. And then for anhydrite, you can just leave it empty, or you could put pyrite in there or something else. But if we do, we have to change that anhydrite point. So we leave everything else the same. Now this is where the rubber hits the road, right? We've got to take training wells, and we've got to do some test wells or whatever, depending on how, big the data set is. will depend on how long it runs and what kind of training it gets. So I don't know, train with a whole bunch of them, train. And then let it see what it does, right? So it's got like this real time sort of tracking that it's going to do for each epoch, where it's going to tell you how the model is matching what the mean absolute values are, what the residuals are. So like right away, I can see that a couple of iterations into this, my porosity is not too bad. It's not great. It's not pretty awful. 30%. What is this thing? Fucking stupid shit. Started coming up. Can you hear me still?
Yeah, yeah.
Yeah, I've been some shit installed on my computer and it's been so like depending on how this comes out, 2% porosity, 30% saturation, 10% calcite, like 24% quartz. This is not good, right? So we need to test this out a little bit, better using the test and train data sets that we did for the machine learning thing, which I don't remember what those wells were and all that stuff. But the whole point is if we get a comparison, then we can write a paper. We'll have to recreate this work for a public data set of some sort that we don't have yet, which is why I've been sort of saying that we need to do that, because this is where it really comes in handy, having all those public wells. But there's all kinds of different things in here also, right? That the tube, you're kind of tuned into some of this, right? Stuff about how these windows and batch sizes and learning rates and dropout and, the types of neurons in the neural network and stuff, and how the physical configuration of this thing is set up. And it's also doing it by zone. So like if you look at some of these things, I'm telling it to learn all these parameters. And so it's saying like in the Lower Sprayberry, I've got an M value that I'm learning, right? I've got an N value that I'm learning for each one of these tops. The bulk density and neutron endpoints for the clays, it's learning, right? Based off of the equations, the physics equations in here that are set up for calculating clay from neutron density, which is what you're doing in that cross plot. So this neural network is learning from this. And it doesn't seem to be like really improving that well either through these runs, I don't know where we are yet with this thing. It's all froze on me. Maybe done. I think it's done, right? It's done. So you can save the config so that you don't have to do this again. Fill it all out. I think that anhydrite thing, like again, if you come in here, you can change the anhydrite parameters. If they're in here somewhere, I think. There it is, like neutron anhydrite, density anhydrite, PE anhydrite. You can change those to pyrite. And then put pyrite in the model. See what it does. So for the predict thing, I can hit the predict button. And it's going to complain that there's no curve sets. Which it shouldn't do. It should create curve sets, right? There we go. So there's a bug. The first time around, it doesn't create the curve sets, and then once it creates them, it's okay. So then there's like this dashboard thing, right, where you can look at bulk density recreated. There's a bias in that data, right? You can see it. Like, I don't know why there is, but there is. And like, we could have, same thing over here for PE, obvious bias. You know, all you have, it's linear. It looks good. All you have to do is just is rotate it, right? And it would be better. So something's going on where some of these aren't bad. I don't know what happened here. Something happened here too in this book's well. So like digging into some of these, just doing some simple tests and figuring out what's going on. You can see, like, you can scan some of this too to see what happened, right? Like, what did it figure some of these things are? Like, it's learning RW as well. Well, I've got, 2% porosity, 32% saturation, mean absolute error. Like, these values are not good. I think we can do better. And may also be due to that, and then due to how we set up the training data. So, we can try, let me just do this for the hell of it too. I'll put in put pyrite in there. And then so the density of pyrite, where is it? There it is. It's 5 grams per cc. The neutron, I think it's just like 0. I don't even know. PE for pyrite is like 50 or something. Or 80, I think it is. I have to look that one up. And that's it. So if you did like 100 of these, increase the learning rate a little bit, make the batch size a little bit bigger. I don't know, let's see what it does type of thing, Still seems to be really struggling on the mineralogy volumes and stuff. But that's why somebody needs to play with this to figure out if they can get it to work or not. Is this dead in the water or not? I think you're going to have a hard time beating the whatchamacallit, the decision tree algorithms, right? They're always going to nail it better because they're sort of designed around that. That's the whole purpose that they have. But what's interesting from this is, because I have equations in there for saturation and for, density porosity, which, by the way, anybody forgets the density porosity equation, I'm going to beat you with an iron rod, right? Like, do not forget that. Everyone should know that. You should get a tattoo on your arm of the density porosity equation. But because all these things are in here, right, when the thing is done, if it matches reasonably well, the most valuable thing that we get out of it are all these parameters, right? We get an M and an N, and we get, all this stuff too. So that's very useful to know what these endpoints are in my basin, in the intervals that I'm working in, right? Very, very useful to get these things. RW values, like what did I match with, right? Even though these all appear to be very wrong and high, extremely high, actually. I don't know why it's doing that. I guess it has to do with the M and the N that it's using. But yeah, this one's even worse yet. Look, I've got 3% PT now. and my mineral volumes are even worse than they were before. And if you look at the reconstruction on the actual curves, I'm within reasonable bounds, actually. Right? All things being considered, because the tool brochures from Slub or Halliburton or whatever, and we already know this because we did all of that Monte Carlo simulation work. Bulk density is accurate to within 0.02 grams per cc. Well, our neural network model is telling us that already. And it's partially because it's just buried in the statistics of the data, right? But that makes sense to me. The neutron tool is accurate to within like 1 PU or something. So this is a little bit high. PE, I think, is about, that's probably about right from what I've seen working the data for as long as I have. Resistivity, I don't really know what that means because it's in a log form. But DTC, usually about 1 to 2 microseconds a foot is reasonable. So, this is a different sort of beast. But here, let's do this again. So we reran it. We can predict again with it. And it tells me too, when I do these blind tests, right, what my mean absolute error is per well. So I'm seeing like this one, for whatever reason, this Book's ED, this thing is fucked, right? Like something's really bad here. And that's what fixed some of these problems. There's that one. This Book CD, I think, is the one that, yeah, it's got something going on here where you've got like casing data. And that may be a problem too. I don't know. But anyhow, so that's the pin thing. The foundation model is a separate module. And there's papers that have been set up and published already on this sort of approach to things, but it's a BERT encoder that you can train on a large data set, and it learns the relationships from all the curves, and then it's able to use what it learns, similar to how these algorithms work in AI for predicting missing words and sentences. It tokenizes everything. So, like if you've got a section of your well that's missing sonic data, it's got other curves in there, right? This thing can learn the relationships and then predict the sonic data, and it does it like in a 3D volume sense over everything. So I think TGS published a paper. I want to say that there's a model similar to this in TechLog that Slub has, and they're using this already. Published probably 2022 to 2025. So this stuff is not, none of these things are new. It's just whenever somebody figures out, hey, I'm going to throw this at petrophysics data. And those guys in particular, the reason that they kind of were able to publish what they have is obviously TGS has got hundreds of thousands or millions of LAS files. So they like trained it on everything and ran it on everything. And I haven't read the paper. I just saw that on Google, right? I searched for it or whatever. I don't know what Slub's got, but this is something also that, is half baked. It's in there. We need to kind of like, figure out if it's going to work or not, if it's useful or not. Again, I don't think it's a substitute for the decision tree based work, but that's very specific targeted work. And that's kind of how I look at these things. I see, like, if you want to use a analog of the military, okay, if these are military tools, the work that you're doing now, where you're finding offset wells, you're building correlations, normalizing data before you do the correlation work so that your correlations are very tight, stuff like that. This is equivalent to like a Navy SEAL team or a SWAT team, right? Going in and doing very careful, precise work. these sort of things like this foundation model and physics informed neural network are like the army, right? Like that go throw grenades across the kombucha border at the 7-Elevens in Cambodia. You know, like that's what these things are. They're very blunt, so to speak, right? They're not going to give you the exact answer, but they still could be very useful. But we just need to like this is another incredible paper I think that could be published if we can figure out how to do this, would be compare everything, right? Compare a foundation model, BERT encoder, compare the PINN, and compare, decision tree based work all on the same public data set, and actually show how these things how good they are, right? Because that's the kind of paper that I think everyone wants to read, where you go to one of these trade shows or something and SLUB is there with their hired sales guys that are greasy and slick, and then, oh, you got to do this, man. We got the best that there is. Our guys at the lab, they're really smart programmers and they got the best in artificial intelligence. And we got this model now. Pay us $100,000 and we'll give it to you. And nobody knows. All they know is what they've been told, right? So they've been told this thing can predict data. It fills in gaps. It's incredible. How accurate is it? Like, if I buy it, is it worth paying that money for something that has really poor accuracy? Like we just sort of saw with that PINN, and publishing that paper is huge because now you're telling people here's a known standard, multiple linear regression even. If I do MLR on wells and I predict everything, how does this compare? How does this foundation model compare? I don't know the answer because I've never run this before. This is all new to me. So I have the feeling that it's not going to do that good of a job because there's, this is not the fucking Peter Pan universe where we all just fly around and, eat magic food and wave fucking, there's fairies and shit, right? Like this is the real world where life sucks and things hurt. And I don't see how there's any fairy magic that's just going to make one of these fucking general encoders learn everything better than a decision tree, right? I think decision trees are the ultimate, like they're designed to learn, right? They overfit. That's what they do. They get it exact. So I don't think it's going to hold. But again, what TGS claims is, you can train this on raw data. I mean, think about it. You could grab a whole volume, just throw some bad hole flags in it, and train this on 10,000 wells. And that also may be what's necessary to get some of these algorithms to the point where they're useful, is that you have to have a very large train data set. I want to say Schlumberger's paper that they published said they used 18,000 wells. So, we don't have anywhere near the capacity to do that anywhere with data that we own, right? But I think we could do a very meaningful paper if we can get a decent public data set built out in our IP database, which also may involve, I've got tons and tons of wells that I've already downloaded from university lands and from the Railroad Commission and stuff. It's just that a lot of that data is missing stuff and it's kind of trashy, right? But that's perfect sort of thing for one of these, where you say, I've got everything. The only thing I'm missing is resistivity because the operator didn't include it on purpose because they're assholes. And then the foundation model creates resistivity curve for you. So then it becomes a question of, okay, is that legit or not? Is that something that I trust? Should I be creating resistivity data? It'd be nice to have some blind holdouts to check it against, to see how bad it is. But how you set this thing up, you know, you can kind of come in here, and I don't do the scanning on here. I just kind of like, you know, tell it which curves to learn and all that stuff, and select the wells, and then you can kind of come in here and set up these different properties. And this is very beta testy, right? Or with, you know, normally you don't present this sort of stuff to the user because they have no idea what any of it is. But that's why we've got this nice little help file now too. So, you know, if you want to come in here, you can click on one of these and say, oh, I want to learn about interpretation. What the fuck does this thing do, right? Formation recognition, foundation model. So I come in here now and it tells me this is what's happening. Maybe I don't understand all these things, right? I don't necessarily need to, but what I do need to know is I want to check, okay, like what's a warm-up epoch or whatever, right? I can come in here and I can look at these things. All right, well, that's training passes, that's the learning rate, right? That's my L2 regularization, number of wells per batch, et cetera, et cetera. So it tells you how to run the thing, right? Configure the curves, predict, visualize, config. So if you just run this real quick, that is. I'm still like a lot of these things. You can't, it's going to fail on because it's unresolved, right? It just picks everything. So the easiest thing to do is like, we'll have to set up a configuration file and then save it. So we don't have to redo this every time. So it says, okay, ready to train. And then this is GPU accelerated, I want to say. Let's see. Didn't pick the curves up because of this curve. It didn't pick up the damn curve set. Can't do that. I don't know if I saved one of these already. I don't think I did. But anyhow, see if you can figure it out. Give it a spin. In between now and then, I'm going to try to get to a land where the internet isn't shit and get this language model situated. And for the Mustang draw stuff, I'm going to hit Ben. I'm going to hit Ben right now. Also, I'm not sure, sending a message. Notice a lot of the wells that have your count rate. So the Mustang draw thing, I'll need to get that survey. I'll send a note here to Jake. And Jorge, I guess. Spoke with Daniel and Beck, good to go on this project. We need a 3D survey outline though to figure out where the wells are generally, and then we'll load everything and sort of filter based on your API list that you provided in the PowerPoint. Any clue where one might find this survey file? Thanks. So once I get word back from them, what I'll do is I'll go into our main database that's like 5,000 wells or whatever, and I'll extract. I'll do some queries against the SQL database stuff I've got and see if I can extract all of the wells that they want looked at. And so then once that's out there, I'll put it on the network and send a link, and it'll be the same thing that we did with Hobo Gypsy, which I don't know if you worked on that or not, or if I did all that work myself. But the initial steps of it are going to be just cleaning up the data. And then if at some point down the road, I suspect that they're going to want this regardless, we will need to do all the rock physics work on the wells with shear. So,
Yeah.
you know, that's a specific workflow to clean that up and get Poisson's ratio values and stuff that are tracking the trends for those reservoirs, right? Because I think he doesn't need the shear to do a post stack, but he likes it to tie the low frequency model. So, and we'll probably need it at some point in the future if they decide to go to pre-stack, or regardless, the work needs to be done because these things feed other models, right? They feed geomechanic models that David Jenkins is working on and so forth and so on. And having that shear data cleaned up helps. So I see value there in doing that. So. And then we've got probably another project coming from Daniel on the grant side of things, you know, once he gets back from vacation. But yeah, for now I think we'll do the Mustang draw thing and then try to crank out this work for Pinion and get them to go away because they're like a thorn in my ass at this point, right? We finished the project and now they want to linger a bit on all these prospects. So the other thing that you kind of need to do, if you can, with that one, I mentioned this to Eric in a few emails and in person already, is that the part of the Central Basin platform that they're playing around in over there, where this well is that you've got from Pioneer, there's a Mississippian slide block. Right? It's a chunk of the platform that broke and fell off into the basin. And there's all kinds of shit going on there, right? Specifically with stress and faulting because a chunk of the basin broke off. So have a look. There's different shape files and things out there. You know, try to orient that stuff to the large picture geology. And understand where these wells are in relation to that, because that's going to impact. So I'm trying to find here, Permian Basin, Mississippian Lime slide block.
Mhm.
The West Texas slide block.
At Texas. All right, maybe we'll look at that.
Yeah, because I mean, this significantly impacts the Barnett Formation, which is sitting right on top of it. But we need to know where that is. And I cannot find BG, maybe might have something. This would be a good Claude question too. You know, I ask it, hey, find me let me just do that. New session. Find me a shape file for the Permian Basin, West Texas slide block in the Mississippian. See what it says. It says, fuck you.
Cute.
I don't do that. You know, I've been having so many problems with this AI lately. I don't know if you guys have also, where it tells me like, no, it just says, no, I'm not doing that. I ask it to do things and it says, no. It's troubling, right? Like I'm paying money for this and then I ask it to do something and it says, no. Like, for example, yesterday I went to Micro Center. So I need to reconfigure my storage
Mhm.
stuff, you know?
Yep.
Like my hard drives are full and SSDs are incredibly expensive right now because of the AI bullshit. And I figured what I would do is buy one external SSD, a cheap one, you know, Crucial 2 terabytes or something, and then copy all of my IP databases onto that or something, you know, and then use my spinning Rust, what they call it, right? The mechanical external hard drives I have, like in WD passports, I use those then to as a backup, you know. But that's it's an easy thing. So I went to Micro Center on Sunday, and I never seen so many people there before in my life. Like the line was all the way into the back of the building, like into the warehouse part. You couldn't even see the end of it. And I asked one of the guys working there, I said, what the hell's going on? He's like, oh, he says, well, Saturday we were closed because it was raining very heavily. And I thought, well, that's kind of weird because, you know, normally nobody closes because of rain, like not unless there's a hurricane or something, you know. So I went to Walmart, which is right next door. I needed a mouse also because I had had enough of this Bluetooth piece of shit. I threw it away. Like it just the electromagnetic interference from a little monitor throws it off, you know. And I was talking to the girl in the Walmart electronics section, and I said, yeah, I wanted to go buy some things at Micro Center, but it was closed. She says, oh, she says, yeah, didn't you hear what happened yesterday? I said, what? They told me the store was closed because of rain. She said, oh, no. So all these people were at the store on Sunday because it wasn't open on Saturday, right? They all needed things. And there's so many people in Houston that, you know, there was like 10,000 people in the store or whatever. And she said, no, the reason it was closed on Saturday is because somebody went into the store and killed themselves. So I said, you know, how do you know that? Well, she said it's all over the internet. So I go into Claude and I say, hey, dig on the internet and find some information about the person who went into Micro Center and killed themselves, you know. And it said, no, I'm not going to do that. This is morally incorrect or whatever. Like I refuse to do. I said, what the fuck is morally incorrect about it? I just want to know what happened at the Micro Center. And it just argued with me. It's like, no, I refuse to do that. This is like morbid and you shouldn't be looking at these things. Like, who the fuck are you to tell me what I should and should not be doing? You know, you're a fucking LLM. Like you do what I tell you to do and shut up, you know? But isn't that nice? You were in that Micro Center not but a few weeks ago and somebody blew their brains out all over the laptops.
Oh.
Welcome to the USA. Now are you starting to understand like why it's fucked up here? Because this shit happens every week. And it's like it's not something that, you know, is so remote or distant that it doesn't affect you. Like I could have been in that Micro Center when that guy blew his brains out, or woman. I don't know who it was.
Oh.
And it affected me because I couldn't buy the things that I needed to buy Sunday because of the line, because it was closed, because it was an active crime scene for the entire day Saturday, and they had to clean all the blood and body parts off everything.
Oh my God.
Yeah. I was even gonna like ask the lady. I thought I shouldn't say that because it's too soon, but I was gonna say, did they kill themselves because the prices were too high? Actually, Micro Center's got pretty good pricing. So the AI actually seems to have downloaded here. I'll put it in the chat. Downloaded it to my computer and put it in a folder. And
Okay.
the downloads, and it's in a folder called Horn Permian Basin Faults. So I didn't load it yet, but next week, I think it is, Brian Coffey will be here. So he is an old friend of mine from
Mhm.
Apache. That's
Right.
a rather good geologist. Let me add this to IP and see what this looks like. He knows where all the bodies are buried with this sort of stuff, right? You ask him. Well, really, he's good. He's good with it, right? Like he knows. If I asked him that question, where can I find? Uh, let's see what this. Where can I find that slide block shape file? He would know like right off the top of his head. So the faults themselves, that's useful to have because you can see everything nicely. I believe it looks like it's just on the Delaware Basin side. There's nothing in the Midland Basin. But it's somewhere in Winkler County, I want to say, where that slide block is, and I'm not seeing. There's just lots of fucking faults is all that it is. But anyways, at least you could kind of plot some of these things against where that well is. The closer the well is to any of these major faults that are in the Mississippian or Barnett, and I think there's like a basement fault map, right? And then there's I don't know where the framework faults thing is at. There's a README file in there. Let's see what it says. Uh, I don't know. I guess we just have to assume that the basement faults extend up into the Mississippian. There's also there's a throw attribute that you can plot on the thing, I think, to see what the throw is. It says the CC0 shape files are basement rooted faults that propagate up through the Mississippian, which is exactly the structural framework that bounds fault blocks in West Texas Permian. So it didn't seem to understand that I wanted that misaligned slide block. But anyways, go off of that. That's something better than nothing.
Got it.
PEG's got this. PDF file. Oh, I can't find. Harper should know all this stuff. Why doesn't he ask her? She's his wife, right? Like Harper
Yeah,
knows all of these
right.
things, damn it.
Yeah, Harper should
Just
know.
send a message to her. It's easier just to do that. Like, maybe I'll just send her a text message. It's easier. Because she's at lunch right now anyways. Harper. Hey, Eric was asking about that Miss Slime slide block stuff that Brent Riley was drilling, the black and brown bombers. And we're looking at that for him, but I don't have any shape files or context on those faults and that slide block. You may want to have a chat with him about that. I know that you know a lot about that, so no reason to reinvent the wheel, and you're probably arm's length from him. Isn't that something? Married people and they both talk to us, but they don't talk to each other.
Yeah.
This is a good lesson for you to learn about the role of communication in a marriage someday, so that you don't wind up in the same boat. One should talk geology at the dinner table. All right. Continue, bang out that well for Eric, and they've got a couple more coming. My understanding, Greg is looking for some stuff. I don't know. Look in our public database.